we're going to be doing now is something that is called we continue with plots, okay? Because plots are very useful and we're going to use them all the time. So let's do, we have done blah, blah, blah. I think we can do, yeah, perhaps some 3D arrays. So let me show you, let me tell you first of all, what is a 3D array? This one here. Let me move this one here. Okay. So if we do a 3D array, where is this one here? Yeah, let me see what's going on with my mouse. Why it's not working? Yeah. Okay, guys. So remember during last class also what I did is I show you what is a 3D array. Okay, as I was mentioning to you guys in the previous video, and guys, you need to review because we're going to be building up on this knowledge, okay? So in a couple of classes, we're going to be doing already programs. So, and from these programs, you're going to be using all the things we're doing here. So a 3D array, guys, is basically a collection of matrices. Okay. So
Professor, I hate to cut you off, but one quick problem though. The videos that you uploaded, half of the graphs we can see. The ones that I could recreate it, I recreated it. But they're just the stock ones, those are just not possible.
Yeah, I was telling to everyone, try to do that. If you're not able to do that on Wednesday, we're going to come back to the ones that you cannot, because some of you haven't been able to even work on that. So everyone is going to try to recreate the graphs, and the ones that you have issues, we're going to do on Wednesday.
And when do you want the homeworks to be submitted then?
You know what, can be not by Wednesday. We can say Friday, Saturday. I don't care. We're gonna catch up. Don't worry.
Thank you.
Okay, so remember this is a collection of matrices, guys, and as usual, number of rows, if we call this n, if we call number of columns m, and what we do is we simply stack the matrices one after the other one. Okay, so this dimension here is that we can call it p. So number of faces represents a p. Okay, so this is a 3D array. Now, what we can do also is we can do a 3D graphs. Okay, so basically how a 3D graph looks like is something like that. No, if you have your x, your y, and your z. So if you just imagine, guys, that XY graph. So you have a point here. This is your XY, correct? But then now what you have is you have a third dimension. And the third dimension is basically the height. So for example, you're going to have this point here is going to be my X, Y, Z. Okay? So you're going to have this volume dimension. Okay? And that's what we are going to be doing today. So let's create an example. And we are going to use this data. Okay. So any questions here, guys? So we can go to MATLAB and then we start playing with that. Okay, so let me go to MATLAB now. Yeah, let's create, I will create panel data. And we're going to use a lot this time. So let's create just numbers, 100,000. And I will explain what is this, okay? Oh, I need to define my panel data. I will define this as, sorry, this is not, I want to make this all one. So what is the reading of this one here? This is also part of the previous video. So when I define with 3 dimensions, what I'm telling MATLAB is please create an array, right? So the first one here is going to be rows, columns, and faces. Got it? So when I introduce the data in this way, what I'm telling MATLAB is, okay, these are going to be all my rows, all my columns, phase number 1. Got it? And please create this one here. Oh. You see, so this is going to be the first phase of my array. Right? So let's assume that this one here corresponds to the following. So these are years. If you go row, the rows is year 1, 2, 3, 4, and 5. And columns represent simply individuals. Right? I made a mistake here. Sorry. I made a mistake here. So this should be is 1 less 0, just to make it coherent. Okay, so basically what we're saying is that the first guy, and this is also wrong. Sorry, I need to change this one just to make it also coherent. So let's assume, guys, that this guy is one guy that income first year was $1 million, the next year 1,250,000, and then he ended up with 4,250,000. The second individual started with $72,500 and end up having $105,000 in 5 years. Okay, and the last individual was $41,000 and end up in $53,500. Okay, so this is my phase. My first phase is going to be my income phase. Right? Now what we are going to do is going to create a saving phase. And the saving phase is going to be, we're going to start, okay, say this is 2 are going to be my savings. I will simply delete this part here. And my savings are going to be something like $35,000 here. Yeah, I want to use this data because this was real data. Sorry, guys, this is not correct. This is 100,000. This is 1,200, this one. Yeah, it's 1 less 0 on all these guys. It's not millions, it's thousands. Yeah, this is these are the correct numbers. And I will do that too. Yeah.
Quick question, Professor. Just exactly what's wrong with the numbers? Why are you changing it?
Oh, yeah, because these numbers, guys, came from a small subset of Piketty books. Yeah, and that's why I use these numbers. So this was based on a real life example. So this was an individual that was making $100,000 a year. I don't remember. Say in 1990, this is 1991, 92, 93, 94, something like that, or 2001. I don't remember this very well. And these are the savings of these individuals. Okay, so from the 100,000 of the first individual, he saved 35,000, etc. Right? So this is going to be income, and this is going to be revenue. Sorry, savings. We're going to use this graph, this table, or this array very often during this class. So let's work on this. Okay, once you have this one here, we can do the plots, guys. Okay. So now let's create a 3D plot. So for 3 individuals, so let's create X to be 1, 2, 3. Okay, so this is my X is going to be my individual 1, individual 2, individual 3. Got it? And I just want to compare what is the income and what is the saving per individual. So what we do, there are many different things. I will show you all of them. Let's do a plot 3. X is always X, Y, and Z. So what we can argue is that panel data is going to be my income is going to be my second I just want one. Okay, so I want to see what is the income. I want to see what is the income, guys, of during the first year. Okay, income savings relationship of these individuals during the first year. So this is first year, all individuals income. This is going to be my Y, and my C is going to be now I want these guys first year. I want this to be savings. You see, so what I'm doing is I'm plotting X is going to be my individual 1, 2, and 3. Y is going to be my income, and Z is going to be my savings. That corresponds to the first year. You see this one? This one here means observation or row number 1 that corresponds to year number 1. Got it? So we can add more things here. We can perhaps say X label. And then we can write in the X label something like individual in the ID, something like that. And this is my X label. I can do the same with my Y label. I can call it income. And I can write my C label as savings. Okay. I can add, if you want, guys, read on if you want to. Do you remember what this creates? It creates all the lines, right? Okay, let's see. Let's take a look to what happens. Do you see my graph or not, guys? The figure.
We do not.
Can't.
Yeah, so this is where the problem is. I think I need to do a screen. So let's go. Now.
Yep.
Oh, got it. So it is. This was the issue. Yeah, this was the issue. Okay. So things that you can. Let me move this. I can move this one here. So things that you can do here. I will try to move this, make this big. Okay. So this part here. One thing that you can do, guys, is you can move the graph like that. You see that? You can move as you want the graph. So it is up to you where you want to see. But the idea is, how do I read this one here? So indeed, this 1.2, 1.3 are meaningless. The ones that are important for you are this one. This corresponds to individual number 1. This corresponds to the income saving of individual number 2. And this one here corresponds to the combination of individual savings with individual number 3. So then if you want to see the values, you just move the cursor, appears across more or less around 2. You can see 2 and savings. You just click here. Just click. And this will tell you individual number 2, income is $70,000 and savings was $22,000. You see, this was for year number 1. If you want to see for individual number 3, individual number 3 had an income of $41,000 and the savings were equal to $1,000. And if you see individual number 1, so this is basically where individual number 1 ranks, is going to be $100,000 on salaries and $35,000 in savings. Make sense? You can move, you can rearrange these graphs as you want, guys. It's very, very interesting, very powerful tool. Okay, questions? Clear?
I do have a question.
Yes.
Isn't it kind of pointless now? The graph have 1.5 to 2
Yes.
things.
Yes, it is pointless. You know, that's what I was telling to you. So indeed, what we are interested is 1, 2, and 3. Unfortunately, you know, I think there is a grid if you go into edit, something like that. So you can say that the increase is 1 by 1. You can do that. But indeed, what is useful is only the 1, the 2, and the 3. Okay, Jack. Okay, so let's do one more plot. I want you to do the following plot, guys. I want you to remember, if you want to do a comment, you simply write the percentage sign. So this is not, MATLAB is not going to do anything. So I want you to plot income and savings for all individuals, all years. Okay, how do you do that?
Would you just remove the row specifications in the panel data?
Right, exactly. So let me copy this one here because it's going to be the same, right? The only thing is what I change here, guys. If I want all the years, what I need to change in this part here, the titles can stay the same. What I need to change here?
The first one becomes a colon.
Exactly. Guys, everyone understands this part here? So remember that the first one represents years, represents the rows. And column implies simply, when you have a column, implies take all the rows. When you have another column in columns, implies take all the columns. First phase. Right? The same here in the saving part of the equation, column, etc. And that's it. Now, if I don't want to delete my previous graph, what I need to do here? Guys, if I click here, what is going to happen is that this plot here is going to disappear, right? Because the new one is simply going to delete this one here and create a new one. I want to keep this graph and I want to create a new graph. What I need to write here?
Figure.
Exactly. So remember, figure, guys, creates a new empty space for graphing. Okay, in this case, you're not going to delete existing ones. Okay, so if we see this one here, here we go. So you see, so this is the evolution now of income. So for example, individual number 1, what is my income? I had an income of 100,000. This is 100,000, and a saving of 30,000. We can take a look here. You see, he started with $100,000 and saved $35,000, and then he moved in time. This is the 4th year. He was making now $300,000 and he was saving $231,000, and he ended up in making $425,000 and saving $354,000. Make sense? So this is the time evolution of individual number 1. You can see the time evolution of individual number 2, guys, is much tighter. Do you agree? And you can see that the evolution of individual number 3, that is almost nothing. But he makes more money, and he saves more money, but proportional to all these guys here, he's not making that much. Okay, copy up to there, and then we do something similar with a different graph. You know, now comes more fancy graphs that you want to use. Do you have questions? So this is the command plot3. Remember that you add figure is basically to create a new figure, not delete the previous one. So you can see that you are 1, 2 here. If I click here, here you have 1. And here you can have the second one. You see that? You can have as many figures as you want. Make sense to you guys? Questions? No? Okay, so what I will do is I will copy this one here. Well, I don't need to copy, simply right arrow. And instead of plot, guys, plot3, what I will use now is something that's called mesh. Okay, so mesh, you're gonna see just mesh. Just enter and take a look. So this is another way, it's clearer. You see the line here, help us better identify what is the growth of this guy. How this guy is growing here and how this guy is growing here. You see that? So this is another command that is called mesh. And there is another fancy one that is called, I will do the same, that is called surf. Surface. Take a look to what happens. You have the graph here. You see, of course, you can rotate these. You can try to see how this works better for your picture. You can add the plots. You can add legends. You can add whatever you want, guys. Make sense?
Yeah. Question.
Yes, Kevin.
The whole point of doing mesh or surf, as I understand it, is so we can better see the angle at the end of each growth trajectory to see if they grew or not, right?
Yeah, and also gives you a better, because if you compare this one here with a simple plot3, this one here, yeah, it is kind of tricky. Do you see? You don't see where exactly, it doesn't look very nice where the growth goes here. So it's basically it's an improvement. The mesh and the surf is an improvement over the plot3. It's simply presentation. It's very nice. The people use more surf or mesh. Presents better the results. The results are exactly the same. The only thing is presentation. So which one do you use for your paper or your research? Obviously, you want to present the best. But plot3 works decently well too. Okay, guys, questions? It's okay? Guys, okay? So if I want to close a graph, simply write close all down in the command window. Just click close all, and I will close all my windows, all my graphs. So I don't have any more graphs. Close all. But so before going into more array addressing, guys, is very important. Let's start talking about perhaps some text. Okay, so let's do text, for example, a very common text I use. How about this character string? So remember, MATLAB also works with characters, and R also works with characters. You simply need to define them with an apostrophe. Okay, how about this character string? This is a text. If you write whos, you can see T is a 131 character. Right? So how this counts, how MATLAB counts, this is 1, 2, 3, 4, the space is 1, 5, 6, 7, 8, 9, 10, etc. For example, if I just want to capture character, I just want to have this part here. So I need to be 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Okay, so I can start from 16 to 17, 18, 19, 20, 23, 23. So what I can do, for example, guys, is I can say U equals T 16 to, I was saying what, 24? So click and you get the character. So it is exactly the same as a matrix. Each character, including the space, has a position. Right? So if you want to, for example, write character in reverse terms, so what I can do, how can I write reverse? So I want the R to be the first letter, E to be the second, etc. How do I write that?
Professor, I beg your pardon.
Yes, please, Kevin.
What did you say again?
Oh, yes. What I want is to write character in reverse form. So I want R to be the first letter, E to be the second, T the third, etc.
End column -1 1.
What do you think about that?
I may be wrong. Now thinking about it.
Yes, because remember, if I'm using T here, the end of T is going to be G, correct? So it will write everything in reverse. So if we do this, okay, let's call this not U, let's call this U1. It will write everything in reverse. You see? So if I just want to write the character, the word, so you know that character goes from 16 to 24, right? Agree with me, guys? So instead of N, what I need to write here is 24, and I will stop where? 16. Yes or not?
Professor, you have an E in front of the 24.
Oh, not good, not good. Okay, so boom, -1, and then that's it. So you have it here.
I mean, I guess the question here is, couldn't you just did a U1 equals to U n to -1 to 1 since
yes, of course,
character?
Of course. So if you do U3, okay, there's going to be U, in this case, N, yes, N to -1 to 1. That's correct, because U is already only character, do you see? You can do that completely right. Makes sense, guys? Okay, so now what is interesting about MATLAB, guys, is MATLAB is created by mathematicians, so everything can be translated into numbers. So let's create, for example, another one. So let's create S, and let's do A, B, C, D, E, F, G. Oh, A, B, C, D, E, F, G. So imagine, this is not correct. Imagine I define simply S equals A, B, C, D, E, F, G. Got it? Have you heard about the ASCII code, guys? In English, you don't use it because you don't have a tilde. So in Spanish, we have tilde. So we have a U with a small line on top, or we have special characters. Okay, so we use ASCII characters. So these A, B, C, D, E, F, G are numbers. Okay, so what I can do, how do I transform a text into a number? What we use is the abs. The abs is the absolute value, and also is able to help us transform a string character into a number. So let's do abs of S, and you see. So what is the ASCII name for A? Is indeed Alt. You press the keyboard Alt and type 65, and then you get the caps E, A, etc. Got it? So there is a way of transforming letters into numbers. And how do I go the reverse? How do I go numbers into letters? Okay, so what we do, let's call this M1, or let's call this, let's call this M1. It's going to be, set a string, set is str, M. And we go back to the previous one. Okay, so this command, guys, we're going to use a lot. Set a string. Okay, so let's create, for example, n to be equal from 70 to 76. I want to see if there is a string or character representation of this one here. So what I can do is n1 equals set a string and what letters I'm writing when I write this one. F, G, H, J, K, L. Make sense? Makes sense to you guys? Do you understand? This is very simple, but it's going to be very useful. Once you start programming, guys, you want to remember all this stuff. Remember, we are just in the part of the language that we're learning words, okay, and just trying to memorizing words and trying to understand how the words are going to be used later. Okay, so sometimes this is very useful. Sometimes, guys, when you receive data, you have something like that. Year 2000, for example, 16. Oh. Then you have, let me copy this. Some data that comes to you comes in this way. 2017, 2018, 2019, 2020, and perhaps we do 2021. Okay, so if you take a look to what we have these ones here. And these ones here are, are characters. So I cannot do anything with these numbers if I want to have these numbers. So what we can do, guys, is, I just want to remove from this part here, I just want to remove the years. All right? How do you do that, guys? Try with the things that we have learned, just select the years of all this array of X. I just want you guys to capture the years, 2016, 17, 18, 19, 20. Ready? This is easy, guys, so you need to get it very quickly. Okay, so someone can give me a solution. So let's call this y. What I do with y? It's going to take part of x, right? What part of x will this take?
All rows, and then within the columns, just position 3 through 6 in brackets, I think.
Yeah. What do you think about this, guys? Yes. Now, what is the problem with this one here? This one. So this is good, but take a look to y, guys. It still is a character. I want to transform this one into a double, into a number. Okay. So in order to transform this into a number, guys, so let's create z, and it's going to be that the command is going to be a string to num. Okay. So when you go from one number to a string, is set a string. When you go with a string to a number, is a string to num. I'm sorry, I forgot my two. String to num. Then you just click OK. And now take a look to whose. Take a look to Z. Now it's a double. So the command is this one here, guys. String to num. Now, perhaps we continue on this one here. Let's talk about some of the calendar commands that we're going to be using today. So this is do you remember when you use Excel, guys? Also, there are two ways of presenting dates. One is a numeric, and the other one is the date. Sorry, the numeric, and the other one is a month, week, month, day, year. So this is the way MATLAB presents the today. So today is this number. Yeah, but you know what? It doesn't tell me a lot. So I want to see the actual rate. So the command is going to be data string of today. And here we are. Okay, so today is a command. It's a reserved name in MATLAB. Today tells you today. Okay, it tells you what day we are in this format. What you can do also, instead of doing this string, so instead of doing data string today, what you can do is simply write date. If you write date, directly you go to find the date of today. Now there is another one, the now. So this is now, just right now. Tell me what is right now. Remember, when there are numbers, you always transform this one into something you can read, data string. So this is what we are now, guys. Well, a couple of seconds ago. So it was 7 June 2021, 6 p.m., 13 minutes, 6 seconds. Make sense to everyone? Okay, so now let's take a look to when you do payments of bonds or this type of different financial products, and you have a maturity. You normally have, for example, if you have a gold futures, okay, they are going to be paid the third Friday of every 3 months, for example. I'm just giving an name. So imagine, guys, that we want to find all the last Mondays of 2020. Got it? So I want to see what was the date of the last Mondays of every month in 2020. So let's do, this is a name, huh? Monday, let's call it Mondays. Just a name. It has nothing to do. The command that I will use, guys, is lweek date. Okay. 2 is for Monday. Sunday is 1. Monday is 2, and then you continue. I want the Mondays of 2020. Which months? 1 and 12. So this is the week date. L comes from last week date. 2 is a Monday. This is the year, and this part here are the months. Right? So these are going to be numbers only. Well, we can take a look at that. These are numbers, you know. So what we need to do now is, again, so let's call this Mondays. It's going to be a data string of Mondays. And now we're going to have something that is meaningful. So these were the last Mondays of 2020. 27, 24, 30, etc. Now, for example, guys, Martin Luther King is the 3rd Monday of January. Do you agree? And I want to see when was the Martin Luther King from 2010 to 2021. Let's do that. Okay, so let's call it ML Martin Luther King dates. These are names. I'm just imagining names. So the number that we use here, the command that we use, nweek dates. And then what I write is the following. So I want the 3rd, okay, the 3rd of something. It can be any day. Remember, 2 is Monday. So I want the 3rd Monday from 2010 to 2021. Make sense? And in January. Again, 3 is the 3rd Monday from 2010 to 2021. And 1 means January. Guys, I will don't print because it will come up only with numbers. What I've done here, nweek date. Oh, sorry. Nweek date. Yes, the command is nweek date, not week dates. And then I can do mlk days. It's going to be simply date string of mlk dates. Here we go. So these were the Martin Luther King days during the last 11 years.
Professor, question, can we go back to month dates very quickly? So with month dates, you essentially told a computer to give you every single Monday from every single month for the year of 2020.
Yes.
My question is, why did you only get, how is it possible that you only got 12 of them?
Oh, because I'm saying months 1 to 12.
Right, but there are more than 1 Mondays per month.
We have one last Monday per month. This is the last Monday of each month.
Oh, last Monday. So computers automatically do last Monday.
Exactly. So that's why the command is L. This L means last.
Got it.
Okay. Perhaps another one that we use a lot is in holidays. You need to know the holidays. You know, sometimes you don't know if Wall Street is going to be open or not. So we normally use a New York Stock Exchange holiday list, guys. But this is a benchmark for all USA holidays, by the way. Right? The issue with USA is that you have observed versus holidays, but also an observed is a holiday, but not necessarily Wall Street takes as a holiday. Do you agree? So if let's do, for example, yeah, perhaps, yeah, whatever, L dates, just a name. And the command is going to be holidays. What I want is from, I don't know, let's say 2 January 2020. Okay, we can argue, and then we stop on what day is today? 6 June 2021. Or perhaps let's go until the end of the year, so we can take a look to what happens. 31st December 2020. Okay, so what I'm trying to find is, give me all the holidays that were from January 2020 until December 2021. Got it? So we have numbers again. I should have in print this one here. Okay, copy this one here before I do the remaining part. I just need to copy this one. Okay, so how do we transform these ones into holidays? So I can call these L holidays. Whatever, okay. Just be careful that you don't use a name that is reserved one. So it is date string of this one here. And here we go. So 20th January, 17th of February, 10, 25, etc. 24th December, Christmas time, 25th December, 24, etc. Make sense, guys? You know, the other thing, when you pay taxes, guys, when not pay taxes, when you pay coupons, for example, that follow the holiday, you need to know when is exactly the next day. This is insane, but normally you need to the program to tell you when is that. So let's talk about L dates or next dates. This is a name, okay? And I will define next date as business date, BUS date, BUS date, BUS date of, I want, how I call this one here, L dates. So what I'm doing is I'm finding that the next business day after the holiday. Because remember, a holiday can be on Friday, and then you simply jump until Monday. You agree? If the holiday is on Monday, of course, the next business day is on Tuesday, right? And then we do the same. Yeah. Next day. So let's call it. It's going to be a date string of. Oh wow, my name was terrible. This one here. And here I go. Ready? Okay, so let me do a brief introduction of bonds. So we're going to use bonds in a couple of minutes. Have you heard about bonds, guys? I assume you have heard about bonds, right? And we're going to do simply the simplest bond possible. Have you heard about bonds, guys? What is a bond?
Debt instrument. So it's issuing debt.
Right. Okay. So let me introduce you bonds. So have you heard about the balance sheet, guys? So the balance sheet simply presents the financial position of a corporation at a given point in time. So normally every quarter or every end of the year. Got it? So my balance sheet has it's really a balance because it's always balanced. It looks like a table like that. And then you divide this into small pieces, okay? So all this part here is called assets. And I will divide this into two pieces. This part here is called liabilities. Liabilities. And all this part here is called shareholders' equity. Okay, so in assets, guys, you have short-term assets. Okay, no, it's not the topic here. Long-term assets. Now here you have a cash, inventories, accounts receivable, etc. And long-term assets, you have basically equipment, machinery, buildings, and accumulated depreciation. And in liabilities, guys, you also have two pieces: short-term liabilities. So these are basically the liabilities that you need to pay as a corporation in the short term, less than a year. And of course, you have long-term liabilities. Okay, and long-term liabilities are those liabilities that has a corporation that's going to be paid in more than a year. And shareholders' equity, you have ordinary, etc. So the long-term liabilities, guys, are basically represented by, or it is where you're going to find the bonds. Okay, as such, guys, bonds are a long-term debt instrument. Okay, so bonds are long-term debt instrument. Okay, so what is a bond? I will do only one specific case, okay? One simple case. A bond, guys, has different components, and this is called a cash flow. I think we discussed this cash flow. Okay, it's going to have something that's called the face value. Okay, it is what is written in the document, face value. It has a lot of payments. And then normally the final payment, guys, is going to be the interest plus the principal. Okay, so these ones here are called coupons. So this is time. So C is called coupon. And there is something that is called C percentage, it's called coupon rate. Okay, the last day is called maturity. And the last date, guys, normally you pay the coupon. The coupon is basically the interest periodic interest that bonds pay. And this one here is going to be also my face value. When you have this type of bonds, guys, okay, when you're going to lend some money and you're going to receive some interest in the forms of coupons per period, and then at the end of the period you receive your final coupon plus your face value, this is called a bullet bond. And we are just going to focus on this type of bonds. Okay? So what is the question here? Well, the question here is that there are some issues that you need to understand before moving into MATLAB. Have you done discounting, guys, before? Have you done financial discounting? Have you discounted cash flows before? No? Okay, so let's do this very quickly. So what is discounting? So I will do this with just a very simple example, guys. If I have, sorry, I want to know this is my face value. And I have only the following cash flows. Imagine that the coupon rate equals 10%. Okay, and my bond has only 3 years period. So these are years. Okay, so I have 1, 2, 3. Assume that my principal or face value, guys, equals 1,000. My coupon rate is 10,000%. That's 10% per year. Just to make it simple. Got it? So this implies the following. So if my coupon rate, so this is coupon rate. If my coupon is 10% per year, my face value is 1,000. What is the coupon value here? C equals what? C will be simply 1,000 times 0.1, correct? So my coupon rate every year, this bond is going to pay me 100, 100, 100. And the last year, I will receive 100 plus 1,000. Do you agree? Guys, do you agree? Now, the issue with this face value here, guys, is that normally the people call this present value. And you're going to see why this is a correct name, present value or price. So the people don't use face value here. They use present value or price. Why? Because of the following reason. So let's call this a price or present values, present value. So how do I compute my present value, guys? In order to compute my present value, I need an additional rate. Okay, I need an additional interest rate. How is this interest rate called? The interest rate is going to be called the yield. And I will call this I. Okay, the yield, guys, is also in percentage numbers. What is the yield? Is the market, is the desired market interest rate. Sometimes, guys, the market, the fixed income, the bond market competes a lot with exchanges, stock markets. And if something is going wrong in stock markets, the people move their money from the stocks to bonds. So what happens? The prices are going to go up, correct? If the prices go up, what happens with the yield? The yield is going to decrease. Got it? What is the yield, guys? The yield, basically the relationship, so this is yield rate. The yield is simply the relationship between the coupon and the price. Okay? So as I was telling you in this example, if the market requires or wants more bonds than stocks, the demand of bonds is going to go up. So if the price of bonds go up, the coupon is normally constant. What happens with the yield? If P goes up, yield goes down, right? Make sense to you guys? Yes? And the reverse is true. If P goes down, so perhaps the people now they have seen a big opportunity in the stock markets, they move their money from bonds, so they sell the bonds. When they sell the bonds, the price goes down and the yield goes up. Right? So this is the relationship that flows always. So in order to make the discounts, guys, so in order to find this present value, what you need is you need to know this market value. The yield, what is the percentage yield? What is the market price for the bonds now? Okay, now the bonds are not all equal. Okay, bonds normally are classified between, you know, AAA, AA, investment grade, and junk grade, etc. Right? Now, imagine, guys, for this particular example, let's assume, for the example, okay, let's assume that my yield, so let's assume A, that my yield equals 10%. So in this case, what I'm saying, guys, is that my yield equals my coupon rate. Got it? So how do I do the discounting? The discounting, yes, to find my present value is going to be simply, you discount. This is the process of discounting. This 100, I move one period, right? So this is going to be divided by 1.1. This one here is my yield. Okay, it's not this C. The next cash flow is going to be this 100 here, the second 100. How many periods do I need to move to the present? I need to move it 1, 2 periods, right? So it's going to be divided by 1.1 to the power 2. Plus my last 1,100 divided by 1.1 to the power 3, because I need to move it 1, 2, and 3. Got it? So someone can help me with this one here, calculator. I don't have mine. If someone can also solve this one here, please, guys. What do you get?
$1,000 as expected.
Exactly. 1,000. Okay, as you can see, guys, the present value in this case equals the face value. Why? This happens if and only if the coupon rate equals the yield. Okay, when the market request for interest rate is exactly the same as the one that is paid by the coupon, the price, the present value of the price is going to be exactly the same as the face value. Okay, now you tell me what are the values if you have the following. The yield in the market equals 12%. And finally, the yield of the market now equals, let's say, 8%. Can you please compute the price of the bond?
For B, you get about 952.
Sorry.
951.96.
Wait. Can you tell me that? 900?
$951.96.
Yeah, someone to confirm? Someone to confirm, guys, this number. Yes or not?
Yep.
Confirm. Okay, so I will do the formula simply. It's going to be 100. I'm going to discount this by 112 now. plus 100, 1.12 square plus 1100, 1.12 cube, right? And this number here, as has been confirmed by your friends, is going to be 951.96. Got it? So this bond here, you see that when, I will write this, when coupon is smaller than the yield, you see that the price is going to be smaller than the face value. And how do we call this one here? We call a discount bond. Got it? And please help me with the last one. So I will copy here that the formula is going to be 100 divided by 108 plus 100, 108 square plus 108 cube. So please tell me what this number is.
¿No te acuerdas de mi computadora?
No tengo idea, a ver.
¿Se lo entregó?
No, no sé. Cierra bien, por favor. No, tienes que entrar, creo. Okay, guys. Ready? So someone can give me a number here.
$1,051.54.
Someone to confirm. Guys, someone to confirm.
Correct.
Perfect. Okay, so what we learned in this example, guys, is that the coupon rate is larger than the yield. The price is going to be larger than the face value, and this is called a premium bond. Okay, and now from here, guys, you have a very famous graph in terms of bonds. So if this is my maturity, you can have a premium bond, a par bond. Oh, sorry, this is called par bond. So you can have a premium, par, or discount. However, guys, what is interesting is that in time, all of them go to the original price, to the face value. Right? Of course, not necessarily in this beautiful way. You can go just jumping up and down, but you should arrive always to maturity. At maturity, you should be exactly the same. The price should be exactly the same as the par value. Got it? So this is what we're going to be doing now, guys, in MATLAB. Okay, we're going to do bonds, and you're going to see how easy this works. Okay, copy 1 minute, and give me 1 minute to drink some water. Okay, guys, so let's go to MATLAB. You see my screen? Okay, so let's define the variables. Let's say, guys, that we have the yield. Okay, so this is what the market requests. So let's assume that the yield is 0.07. Okay, so this is what the market is actually requiring. Let's do the coupon rate, for example, just any number. Let's assume that this is 0.08. So what happens when the coupon rate is larger than yield? The price is going to be what? Larger or smaller than the face value? Guys.
Larger is a premium bond.
Sorry, guys, it's going to be what?
Larger is a premium
larger
bond.
Exactly, it's going to be a premium bond, right? So now let's do the what is called the settle date. When do we settle the business? Okay, and what we use here is another command, date num. So this is basically going to take a number that comes in character and it's going to transform this into numeric, and the numeric is going to get into the bond pricing. So let's assume that my date num is going to be has been 2 January, let's assume 2020, for example. This is the date, guys, where I signed the agreement. Okay. And let's talk about maturity. Let's assume that the maturity, guys, is date num is on 31st December 2021. So I have the dates, and later we're going to do payments, quarterly payments, etc. We have the yield, the coupon, and that's it. Okay. So what we can do from here is bond price. This is the command. Is BND price, bond price, and we do yield, coupon rate, and then we have settle and maturity. So remember, these are our names, guys. You can change these names as you want. Okay, you can use caps, small caps, whatever you want. These are our simple names. Okay, so if you click there, this is my price. We're gonna do this. We're gonna do more examples, guys, in some time. Okay. Makes sense to you? You understand what is a bond? We're going to do more examples later, but let me move in relational variables. We need to do a lot of exercises here. When I say relational operators, guys, basically I mean all these ones here. Okay. When you use a relational, when you want to say equal, you use two equals, equal equals. Okay. Not equal implies this one here, sorry. When you're going to compare two numbers or two series, and you want to see if they're equal, you don't use a single equal sign. You need to use equals equals. This tilde here implies not, is the negation of the next one, is not equal. Okay, so these are the ones that we are going to be using. So let's assume, guys, that I have a very simple example. It's going to be 1 to 9. Let's see. And B is going to be 9 to 1. 9. Yeah, well, I can say 9 minus 1 to 1. Okay. I'm simply just creating numbers just to create that. Now, when we talk about relational operators, guys, what is going to happen is the MATLAB, what it will do is it will check and verify a condition. If it's true, we'll write 1. If it's false, we'll write 0. So, for example, let's create a T, and T is going to be simply all those numbers that are larger than 4. So what I'm telling MATLAB is, MATLAB, tell me what are the numbers on A that are larger than 4. Do you see that? So what MATLAB is going to tell you, okay, the first 1, 2, 3, 4 are not larger than 4, you can see. And the next one, so 5, 6, 7, 8, and 9 are indeed larger than 4. You agree? Now, for example, I want to know T1. I want to know those elements of A that are equal to the elements of B. So what I will do is A. Here is where you use double equals. So because what you are saying, MATLAB, is okay, A that is equal to B. So equals equals. This is a relational one. That this is what I was telling to you here, guys. You don't use a single equal sign because equal is an assignment. You see, T equals something, so you're assigning. When you do equals equals, implies that you are simply comparing. Oopsie. Well, oh yeah, perhaps I can do. This is a new version of MATLAB. So let me see if this works this way in MATLAB, new MATLAB, yes. So you can see, guys, that the only element that is equal is the middle element. You see that? This is what this one is here telling to you. Now, what you can do, these numbers are numbers. Okay, so what I can do, for example, is I can create Z, and Z is going to be equal A plus T1. What do you think is going to happen? So remember, T1 is a 0, 0, 0, 1, 0, 0. What happens if I sum this vector here with A? A is this one here. So what is going to happen? What is going to happen, guys?
Not sure if you should use individual operation here, but I guess the 5 in the middle will become a 6.
That's it. Oh, well, what I've done. Yes, so I delete that. Okay, so that's exactly what's going to happen. So let's call this T2 is going to be A plus, or no, I call it C1 in any case, plus T1. Indeed, what is happening is simply is happening this one here. Okay, so remember this one here, these logical numbers are simple numbers, 0 and 1, and you can do whatever you want with those numbers, and it's very useful. We are going to do some examples now. Okay, so let's create a small data set. Let me create this one here. So let's create a small data set. Okay, so let's create, for example, let's create IDs and let's create age. So the ID is going to be 1, 2, 3. Let's do 5, 6, 7. Let's do 21. Let's do 18. Let's do 25. Let's do 19. Let's do 22. Let's do 23. Let's do 17. So this is an ID. Individual number 1 has 21 years old. Is 21 years old. Individual number 5 is 22 years old, etc. So can we create this in Excel? Not in Excel, in MATLAB, and let's assume also gender. So let's assume this is 1, 1, 2, 1, 2, just randomly 1, 2. So let's assume that 1 equals men, and 2 equals female. Yeah, male. Yikes. Male and female. Okay, so let's create first of all this matrix. So I will take a picture and copy this one. So yeah, I can create ID is easy, right? ID should be equal 1 to 7. And I can transpose this one here. So I have a column vector. Then I have let me see, H. Let me see, this was 21, 18, 25, 19, 22, 23, 17. And then I have gender. That is going to be equal to 1, 1, 2, 1, 2, 1, 2. This is a row, so I will transform this one also into this one here. Right? And then I will create a matrix that is going to be ID, age, gender. Okay, and this one here is going to be simply the collection of ID, age, and gender. Do you agree, guys? So I created a matrix. Simply.
Professor, you forgot to transpose age.
Oh, you're right. So let me copy this. No, let's do this, and it's gonna provide a mistake. Perfect. And then I need to transpose this one here. So now we have everything. So I can do this now. Here we go. Okay, so now let's start working here, guys. And I will do one example. I'm gonna do a bunch of others. You just need to think. So let's assume, guys, that I want to do a matrix OK drink. Okay, an OK drink are those individuals that are older than 21 years old. So 21 years old included, right? So I want to select, I just want the ID. Okay, so I just want the ID. So I want to use ID, age, gender. So this is my matrix. From here, what I want is simply, I will define what, but I just want column 1. So this is going to provide me only the ID, correct? And I want, how do I define the ones that are older than, the ones that can drink? Simply, the condition is going to be here, ID, gender. Where do I see the condition of drinking age, guys? Where is in which column do I have my age condition? Second column, do you agree? So what I'm saying is from IDH, take these rows that are going to satisfy a condition and give me this column. But what is my condition? What I want to be the condition that is going to be applied to this column here is going to be larger or equal than 21, correct? Guys, I need your input, yes or not?
Yeah.
Yeah, okay, so if I do this, I take this one here. Individual number 1, yes, 21 years old. Individual number 3, 25, yes. Individual number 5 and number 6. So these are the guys that are the ones that are okay to drink. Got it? Okay, copy, and then let's do, you are gonna do a bunch of exercises. So let's do gender of okay to drink. So I will write all of them here. I want the age of females. I want the not okay to drink. I want ID and gender of oldest person. I want two matrices, yeah. M, only males. F, only females. I want to find average age of females. Okay, 5 minutes, guys, to do all these ones here and the ones I imagine to happen in a minute. Three more minutes, guys. Okay, so we are going to have another matrix, guys, that is going to save another matrix that is going to present income and savings. So this is going to be a second matrix, okay? And we're going to start relating two matrices. You're going to see in a minute. 3 more minutes to solve the exercises I gave you. We solve them, then we start mixing up the other questions. Now, guys, what we do here with 7 numbers, 7 observations, guys, you can do with millions of observations, exactly the same. All right, so I've done only 7 just to make it easier and quicker and simpler. Two more minutes and then we start solving this, guys. Two minutes. Ready, guys? Where are you? Have you finished? Guys, have you finished?
Yeah.
Okay, good. So you please help me with this stuff. Gender of okay drink. So I will copy this part here. Oh, no, I don't want to run this one. So gender of okay drink. How do you do that? I will call it gender okay drink. So you tell me, guys, what I need to change in this formula.
Keep everything the same, but change that last one to a 3.
To a 3, correct or not? Yes, because the third column gives me the gender. So, and I have, these are the guys that are okay drink, older than 21 years old, older or equal than 21 years old, and 3 is simply the gender. Good, so I have a male, female, female, male, correct? Now I want age of all females. Age, I will call age females. So I will copy this part here. Yes, so what is the age of all females? What I need to select, I saw it, I need to change something here. What I change?
Change the 2 to a 3 in the condition,
Okay.
and then
Yeah.
change 21 to 2 for
Yes,
female.
and equals, right? Equals
Yeah,
2.
equals.
2.
And then
I need to
yeah.
select age is 3. No, age is 2. No. No, yes, and I need the what a second. What I want here. Oh, I want the age. So age is in which column? No, I think age is 2, right? Females is number 3. Sorry, this is number 3. Sorry, this is number 2. This is correct. This is the number third. The third column gives me the gender. Females are number 2. And what I want is the age. So age is column number 2. Agree with these guys? Guys, do you agree or not?
I agree.
So I have 3 females, 25, 22, and 17. 3 females, 25, 22, and 17. Make sense to everyone? Guys, make sense? Not okay to drink. Well, that's easy. Not okay to drink implies I can use this one, right? What I want. Oh, I want everything. So let's assume that I want everything. I will call this not okay to drink. So this is larger, no, not larger. Smaller than 21, and I want all columns. Agree with me or not?
Yep.
Yep. So these are the guys. Individual number 2, 4, and 7 is male, male, and female, 18, 19, and 17 years old. Now I want the ID and gender of oldest person. So how do I do that, guys? Yeah, we'll call this oldest. Oh my God. So what I do? What is what I want is ID and gender of oldest person. So what I do, guys? What is my condition? How do I find the oldest guy in my sample? What MATLAB command I use? Guys, come on.
I think max.
Yeah, I can do that. The max of all the elements in the column number 2, right? That has my age. So I want, this is IDH from column number 2, find what is the maximum of column number 2, and provide me what I need to provide, ID and gender. So I need to provide which columns? Column 1 and 3. Yes or not?
Yes.
Yes. So here we go. So the oldest person is number 3 and is a female. So let's take a look. 3, 25 years old, and is a female. Now let's create a matrix M, only males, F, only females. Okay, so how do I create M? So let me copy this one that is simpler. Yeah, so males are in column number 3, right? And I want this to be equal to males, and I want all the data. Agree with me, guys? Come on, guys, you need to participate. Okay, next time I will give you control, and you're gonna do every exercise. Okay, that should be a good example. Do you agree?
Yeah.
Okay. So let's experiment. You know, I never thought about that. Okay, who wants to create females only? How do I do that? Can I remote control? Yeah, I can give you mouse control. Who wants to do only females? Jack, Ryan, Kevin, who wants to participate here?
Sure, I'll take a go at it.
Oh, Kevin, yep. So all yours. Can you try?
Yep, trying to get into a, yep, it works.
Yep, perfect.
Professor, I'm finished.
Okay, so guys, F is simply IDH gender. He's selecting from column number 3 all women and providing everything that is all the columns. Do you agree? Everyone agrees with that?
Yeah.
Yeah, perfect. So let's do the next one. What is the average age of females? Who wants to do that? Who wants to do that?
I can do that one.
Okay, Jameson. Here you go, all yours. Just write in here. So we already have the females. That is my column F, okay? That's not my column, my matrix F. Be careful. Oh, yes. H females, where's my H females here? We have defined H females. Yes, we have defined H female. That's good. Easy. Okay, thank you. Yeah, the other way that we can do this, perfect. Thank you, Jameson. So the other way that we can do that, sorry, the average just using can be, if I want to use this one here, I can do, if I want to use F, you see, I can use, if I want to use F here, guys, it's going to be F. What I use from F? Everything, comma, 2, right? If I want to use the IF matrix that I have here, the second column represents the edges. So I use the mean of F2. Oh, what I've done here. Here we go. Make sense to everyone? Perfect. So let's do the next one. Gender of not okay to drink. So I think we have one not okay to drink. 1 second. So we have, where's my not okay to drink? Here we go. So you can use this one here. Now, how do you get the gender of not okay to drink, guys? Who wants to do this? Jack or Kevin or Ryan?
I could take a crack at it.
Okay, Jack, go ahead.
Did you? Oh, there it is. Okay.
Yeah, you have, yes, exactly.
Gender not okay to drink. Okay.
Yeah.
Set up all. It would just be 3, right?
Yep, that's it. That's it. Okay,
Yeah.
so the gender of not okay to drink are simply these ones here. And finally, the last one. Age and gender of individual ID number 3. Yeah, this is piece of cake. Ryan, can you do this? Ryan, are you there? Not sure he's there. Okay, but in any case. So how do I do the age and gender of individual number 3? This should be easy, right? So let's do. So let me call this individual. Sorry. Let's call this individual 3. Okay. Yeah, individual 3 is going to be this one here. Individual ID is number 1. I want this to be individual 3, and what they are asking me is age and gender. So this is 2 to 3, right? Agree with me, guys?
Yeah.
Yep. Here we go. On. Okay, so now let's create another matrix, guys, and let's call it ID income saving, something like that, with the data that I provided. So ID income saving. Okay. And I will do it in a single run. Okay, so this is going to be 1 to 7 transposed. Then I will have the 2 columns. In here, I want 2,100. And I want to transpose this one here too. I want to transpose this one too. Here we go.
Professor, you know what I just realized? You can actually use SQL commands in MATLAB. There's a way to do it.
Yes, yeah, that's cool. Okay, guys, I want you to create a income mouse. Okay. The last ones, guys, we're gonna do together, okay? Okay, 5 minutes, guys, and then we move, we continue. Okay. One more minute, guys. Have you finished at least until, where are you? Have you created arrays already?
No,
Guys?
I'm not there yet.
Yeah, me either.
Where are you?
I'm having a hard time using finding age and gender of highest income. I'm still working on that one.
Okay, so a couple more minutes, guys. And then we do at least these 4, okay? 2 minutes and then we solve these 4. Okay, let's do this and then we continue, okay? So let's create a male income or female income. That's easy, right? Oh, sorry. So remember, it's always, where do I get the data? This is my database. And then from here, what I need to select? I need to select all the columns, right? All the information that are in the columns. Then what is my criteria? So I want these, all the rows. What is my, oh, sorry. This is interesting. Oh, income males and income females. So the thing is that I don't have the information males and females here, but remember the two matrices are related, right?
So, Professor, couldn't you just concatenate a column onto it, give it a 1?
You can, but I don't want to do that. I want to show you just moving the two matrices independent. This is normal. You have two databases and you have one relational that is the ID. Okay, so you know that they're talking about the same language. So what I will do is I will use the ID age. What's the one? ID gender. What is it? So I mix it up here. Here we go. And remember that the first matrix, guys, I want to find all the which column was gender was column 3, right? And I want this to be equal to 2. Do you see with that? I agree with Kevin, guys, that you can simply create a new matrix with all the data, got it? But sometimes, guys, you have such a huge data set, you don't want to concatenate them. So, but you know that they are linked by somehow, and then you simply call from one to the other one. So what I'm doing here is basically saying that my man is going to take this one here based on the ID age gender when all are females. Oh, sorry, no. This is not 2. This should be 1. Males are 1. Agree with me? So these are the males' income and savings. We can do the same for females, so it's going to be called F. And then instead of 1 here, I will want to have 2. Right? Yeah, that one here will be easy, right? So they want a column vector, so it means men and female, the average income female. So we can call this average incomes, ABG income. I'm just creating names, guys. You can call it as you want. And it's going to be a matrix. And one of them is going to have the mean. The mean of, I already have the mean here. But what part of the mean, what a column of men's, all rows, which column? Guys, which column?
2.
2. So this is going to be the mean of men. And I will do, as soon as I want a column vector, so I want below, so that's why I use the semicolon. I will use the mean. Yes, and then it's going to be not M, but it's going to be female. Do you agree with me? So this is the average income of male and females, write them in a single column vector. Here we go. So the average salary of males is 2.02, and the average salary of females is 2.133333. Do you agree?
Yes.
Okay, good. So let's do using ID Anger. Yeah, okay, so we can mix these two things together now. I can find the age and gender of highest income. Okay, so this looks interesting. So let's call highest income. Okay, where do I find the highest income? Well, I need to use, I don't know if it's a male or female, so I need to use this matrix. Do you agree? This is my database. Oh, sorry, what I've done. So this is going to be my database because I want the highest, the age and gender. This is going to be cool because I have the age and gender of the highest income. So no, indeed what I have, where I have my age and gender, I don't have it here. I have my age and gender. I have it in this one here. Correct? And from this one here, I want the age and gender. So age and gender is 2 to 3. Oh. 2 to 3. And what is my so what I put in here, which columns I select? Well, the selector is going to be based on another matrix. Do you agree? The matrix that is called and where's this one here? On this matrix, which column? Which column has all rows? Which column has my income? The second one. And I want this to be equal to what? To the maximum of this one. Do you agree with me or not? So let's read it. I want to have the ID, sorry, I want to have the age and gender. And where do I get this information? I get this information from a matrix that is called ID, age, and gender. What is going to be what rows I should select? Well, this depends on information in another matrix that is called ID in income and savings, column 2 that contains an income. And I want to identify the individual that has the highest income. So that's why equals max of ID individual saving number 2. Do you agree with me? What about, guys, if you want to add to this one here? So let's do another one. Add to the resulting matrix. The highest income. How do I do that? I want you to add, okay, I know that this is 25 and 2, so this is 25 years old, it's a female. I want here the income that corresponds to this person. You can use this highest income. Yeah. I will call it just.
Professor, I can do it if you want me to.
Yes, please. Okay, Kevin, you have it.
Interesting. I can't paste anything.
I don't know. Yeah, that's interesting. I know.
I guess I'll type it in.
Yeah, type it.
Not very convenient, but
Yeah, it's interesting. Yeah, I don't know.
security mechanism maybe.
I don't know.
And then I think I need to Oh, Jesus. What did I write? Okay, yeah, no.
No, that's it.
No, I know what I'm doing. Hold up. I forgot to add something. Yeah, I got messed up because I thought I copied it, but I didn't. But
yeah. Yep. Do you agree, guys? So there is a new command here that is called, Horse concatenation. Makes sense to you guys? You see that? Now, another possible solution is simply, instead of using this one here, you can create in MATLAB directly the matrix data. So, but you need to be sure that you use brackets. Make sense? So the horizontal concatenation, guys, what it does is basically transforms. If you have different pieces, you simply put horizontal concatenation, comma, 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 etc. Okay? If you don't want to use that, the more traditional MATLAB, that is simply use bracket, bracket. That's it. So the bracket, bracket replaces the horizontal. And also we have vertical concatenation. So instead of using vertical concatenation, you simply use semicolon somewhere here. What is that? Here. Instead of this comma, you use semicolon and simply do down. Okay, guys, questions? Do you understand? Clear? Yeah, you know what? This one here is guys, this is data management. Okay, so what we are learning now is simply how to handle data, how to make simple analysis when you have millions of rows of data. Okay, instead of millions, we have 7, but the logic and the principles are exactly the same. Make sense? So you need to manage this because in the programs, I will assume that you really are experts on this stuff. Thank you, Karen. Yeah, okay. So I want now to have this one here. Can I give you 3 more minutes and try to solve the remaining ones before sorting? Yeah, you can, I'm pretty sure you can do that. ¿Qué pasa contigo? Ah, no, ¿no tienes tareas? No. ¿Cuánto es quick break? Tienes que hacer tu tarea, hijo. Tienes media hora exacta y ahí te ponen a hacer tu tarea. One more minute, guys. Someone wants to do this? Guys, someone?
I can go if no one wants to go.
Yeah, okay.
Okay.
Okay, Karen, you have it. Yeah.
Okay. Well, first of all, I'm gonna do something, Professor, you're not gonna like, but we're gonna go with it.
Go ahead.
Okay. We're gonna create a master table because we're trim professionals here. Horse cat, and then we're gonna. Oh, did I do it? Or, no, we did.
Yeah, you can do it, Oscar.
Horse cat, and then ID. What do we call it?
H, I think it's ID H gender, and the other one is ID Inc safe. Yeah. Gender.
I think I'm gonna. Okay, yeah, I think I'm gonna start with ID Inc saving.
Yeah.
Just because that makes more sense. ID, age, gender, right?
Yeah.
Okay, and then we're gonna have to erase because we don't want to duplicate in column.
ID, yeah, right.
So we have already
Yep. Perfect.
closed it, and then I think we gotta close it again. Yep.
That's it.
Go to master table, and then you wanna. What do we want to extract again? We want to extract ID, salary, age. So at that point, so we're gonna call this one ID,
Yeah.
salary, age,
Gender, yeah.
gender, over 18.
Mm-hmm.
Super long name, not efficient, but okay, so we're gonna go to master table, and then master table. What I will do now is that I will now select the column with the correct age in them, in this case column 4.
Yeah. Mm-hmm.
Set larger than 18. And then I will effectively, what do we want again?
ID,
1,
salary, yeah,
2,
age,
4, 5.
and 5. That's it. Mm-hmm.
Yep, and then
Yep, that's it.
and
Yep. Thank you, Kevin. Do you agree with that, guys? Jack,
Yep.
Ryan, Jameson.
Yeah.
Okay, so now what happens if we don't want to concatenate the variables? I agree, and this is completely valid, guys. It's a very elegant way of doing this stuff very quickly. Now, what if we don't want to join these matrices? Let's use the same, this one here. Let's call it B1, something like that. Let's do this very quickly. So let's call this B1. So how do you do that? So I can have it's the same as horizontal concatenation. So what do we need from here? I want to select, I want ID, salary, let's go first with ID, salary. So I can do, it's going to be more complex, but it will be ID, age, gender, correct? I want this to be the one that is going to be everything, comma, 2. This is the larger than 18, correct? Up to now, that's what we want. This is the one that is going to be what I'm doing here. Serial. So what I want from here, guys, is from this matrix here, I want to have the ones that are larger than 18, older than 18, sorry. And from here, I just want, unfortunately, I need to do this. This is going to be longer because I want 1. Agree? So this is my first column. I'm selecting those IDs of individuals that older than 18 years old. And then I have one more that is from ID, where you created this one here, ID, this one here. So then I do this one here. My condition is exactly the same. Take a look. So I'm selecting the ID. From this one here, the condition is this one here, and I want to select, what is that? It's only salary. So I want to, salary that is income, 1, and no, not 1, 2. Then I need to put close to this one here. Now I can finish this one here. Da, 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 18, but now I want 2 to 3. Do you agree, guys? Make sense or not? So I want to create a horizontal concatenation. The first part from here, I select the ones that are older than 18 years old, and I just want to select the ID, this one here. So this is the first one, the ID. The second part is simply selecting the ones that are older than 18 years old, and I want to select the second column of the matrix that has an income. And then finally, I join with the age and gender that we met here. And we have exactly the same, right? Make sense? You need to be familiar, guys, with all this stuff. And remember, when you do your own programs, it is your call. You can do either way, okay? That the one that is easier for you to understand and to manage, do it. Okay, I'm not going to be trying to force you to go in one direction, because programming, guys, you can have thousands of different directions, and all of them are going to be correct, but perhaps not as efficient on all ones, but it works. Make sense? Yeah, I think that I can jump. Yeah, how do we create an array? How do we create an array, guys? So let's call this array data, okay? Simply like that. And remember, if you want to create an array data, guys, you need to define, first of all, this one here. So this is going to fill all my rows and columns, phase number 1. And this is going to be equal to, I think I said this is going to be equal to what? ID, salary, age, gender. So it's going to be more complex than simply putting this. I want ID. It's a matrix. Oh, come on.
You can just use my table, Professor.
Yeah, I think it's much easier. Okay, I will use this table, guys, just to do it faster. So I will use from here. I want what I want is what? I want ID. This is 1, right? What else do I have? 1 ID. Salary was 2. Yes. Age was, let me see. Age was 4 and 5. I think this is correct, the first part. And I want all columns. You agree with me, guys?
Yeah.
I don't need this part here. Sorry, I don't need this part here. This is simply this one here, because I have already the master table. The grid from the master table take columns 1, 2, 4, 5, all rows, and this is going to be my phase 1. And my phase 2 is very similar to this one here. However, the only thing that changes is that I don't use this one here is going to be 3. There are savings, correct? This one here. Oh, what do you mean by you don't have savings? Oh, sorry. Here we go. So if you want to see that a complete array, you just click this one here, and then you see phase 1 and phase 2. So we have 1 and back of the other one. Correct, guys? Make sense? Yeah, you can do that. Yeah, that's easy. If you want to shift the savings to the front and income to the back, well, what we do is simply this one here. You want to respect the number of columns, the content of the rows of the columns. And the only thing that you want to do is you want to go from 2 minus 1 to 1. Agree with that? Uh-oh, what have I done? What they are equal? Wait a second. So 1, 3, 4, and 5. So I think we have done something wrong. 1 second, guys. Yeah, let me see this one here. Let me see this one here. So we have master table. 1 is ID. 2, what is 2? What is the master table? Where we have defined the master table? Oh, here. Right. So it's ID, income, savings. So, but savings is 3. That's correct. Age and 5. Yeah. Okay. So we have master ID 1, 2, that is income, 4 and 5. Do you agree with that? So this is correct. No, it's not correct. Oh. Yeah, it's not correct because I just want this part here. Yeah, perfect. Okay, so now we do the second one. And this second one is going to be 1, 3, master table 1, 3, 4, and 5. Why this is not working properly? Yeah, I should have been made a mistake here. Master table 1, 3, and 3, 4, and 5. 1, 3. Okay, you see the mistake. Where's that mistake here? I think we are doing something wrong. 1, 3.
Nothing wrong with the table. Maybe the command that we extract, because it is effectively giving us all 5 columns here. It didn't give us 4 like we asked for.
Exactly. Exactly. So what is going on here? Oh, no, of course that's wrong. I know what is wrong, guys. Master table, this one here. These are columns, they are not rows. So this should be the opposite. You see that? Is all rows, these columns. What do you mean by that? Oh, yeah. Yeah, because I destroyed already the matrix here. So let's do this. What I will do this, we'll call this one here data array 1, okay? Okay, now it works. Now data array 2. Do you see, guys, what was the mistake? The mistake was I was using the rows instead of the columns. So I made a mistake there. So now we can see data array 1. Here we go. You see? I have the income and the salary. So now we can do the reverse of this one here. So if I want data array, want to respect this, want to respect this.
Can you go back very quickly? I didn't catch what you did there. Because I'm still
Yeah. So let me Go back. So what we have done is this one here. Here we go. Here we go. The mistake was that we put this one here before the column was in here. So now what we are saying is all the rows and give me these columns. This is for the second phase. For the first phase is give me all the rows and only 1, 2, 4, and 5. 2 is the income. Make sense?
I don't know why, but my table is refusing to run for some mysterious reason.
Yeah, can you run your master table? Take a look to your master table. Perhaps we have made. You need to change. Oh yes, of course, guys. You need to change the name. Otherwise, you do clear array data, because if you try to impose this one here,
so we created it already.
Create a new one. Exactly. We have created. No.
Got it. Yep, that works now.
Perfect. Guys, do you have questions? Jack, Jameson, do you have questions? Ryan?
So the issue was essentially just how you were naming or how you were identifying the array.
How I was identifying the columns and rows? I was making a mistake. I was doing these ones as rows and this one as columns. You see, that was wrong. We wanted to keep all the rows.
Okay.
We wanted to keep all the rows and the specific columns. Okay, guys, we stop here. We continue next Tuesday. Guys, you know what? The next the next 3 classes are going to be crucial. You know, it's very fun. You know, just play with this stuff. Go home. Well, you're home already. Yeah, I'm used to have you in classroom. Go back with this one here, review this one here, do the same exercises one time more, once more, twice, etc. Just get familiar with the way this works, okay? Once you get familiar with the way this works, MATLAB is going to be extremely simple. R is going to be extremely simple, guys, in just understanding how this works. Got it? Okay, so I asked already for Kevin, to have the recording as soon as possible. So they told me I will call them tomorrow morning early, and then hopefully we can get this for tomorrow early or something like that. Okay, I will keep you posted, guys.
Yeah, just a word, Professor, after class.
Yes. Okay, guys. Good.
All right, thank you.
See you
Have a
later,
good night.
guys.
All right,
Take
thank
care.
you, Professor.
Good night,
Bye.
guys. Take care.
Have a good
Bye-bye.
evening.
Good evening. See you guys. Where is this part?
You might have to removing.